Welcome to another GCBASIC tutorial for the PIC AS. This is part 20 summary. I'm going to pull it all together in a couple of diagrams so that you can understand what's going on. So please like and subscribe this video and subscribe to the channel. So summary, got all that. So I've explained many times that GCBASIC is an open source compiler for PICs, AVR, LGTs, and I've shown you that it now supports the 18FxxQ35 chip families. You know, there may be issues, I cannot deny it, but we've done an extensive set of tutorials to test and stress test this particular chip family. You can write code for the Q35 and it will work in general senses across all the other microcontrollers. We've seen how the core compiler takes your source code and your libraries, takes that into a preprocessor, translates that into code, into assembly, links it out and generates a hexadecimal file specific to your chip, a Q35. We've also seen how we can reroute the assembler so the linking is done in other tools. I actually shown you in these tutorials PIC AS, MPASM. And we call GCBASIC the GCBASIC linker piece of the code. Very stable. And what we're looking for there is other capabilities when you externally link that code. So let's have a look at what we've covered in terms of the scope of the microcontroller. On the core architecture, top left there, we've covered most things apart from the low power modes and watchdogs. They're supported, just haven't got the time to cover them. In terms of timers, we've covered majority of the timers because they're all very similar. In terms of analog, bottom left, I think we've done everything that we need to show you, but they're all supported. Even though I haven't done a tutorial or a demonstration piece of code, you can use them. There are VFR commands, there are DAC commands, and operational amplifier tutorials. Just go get that piece of code from the GitHub or your local copy of your demonstration files and just look and apply it to this particular microcontroller. In the middle ground, the digital peripherals, we've looked at CLC. There are definitely CWG demonstrations, go get them. In actual fact, there's supported NCO, there's many demonstrations for that. There's many demonstrations for CCP, PMW, that should be green, to be quite frank. MCP, we've seen that in depth, and obviously the serial, we've seen that in depth. Zero crossing, fully supporting. In terms of the system modules, top right, the only thing we haven't looked at really is CLC. The rest we can go and have a play with, look at it. And the only thing in the digital peripherals in terms of the core piece is zero crossing detect. It's fully supported. Just go figure it out, look at the data sheet, look at the examples and other demonstrations, and it will just work. Special features, they're all fully supported. So we've seen great capabilities for this microcontroller. And how does that diagram map to what we've seen? Core architecture, we've tested that with LEDs and reset programs, EEPROMs and serials. Timers, we've seen that in terms of using timer overflows, pulse width modulation, and 16-bit timers. Analogs, we've used the ADC. We've actually used the voltage reference because that's part of the ADC. We've covered CLC, the logic demo, and we've seen PWM in terms of 6 different ways of doing pulse width modulation. Top right, we've used external controls. We looked at the tool chain and how that works with pulse width modulation and serial communications. And then we've gone through many of the modules in terms of the CLC, PWM, I2C, and I haven't gone through all the demonstrations of the GLCDs. There's 35, well, maybe 40 of them. I just picked 2. We've seen serial, I2C, SPI, lots of different examples out there. We also looked at toolchain and debugging. assembly and debugging. I've shown you how to get the code, look at the code, and debug that yourself. And all the other components like ID lock are all fully supported. You just have to use the registers and the register bits. And I've shown you how to actually address those registers. You just assign a value or assign a bit value to a register bit, fully supported. So wanted to show you that diagram. It shows you that what we've covered in all the tutorials in the past. Absolute terrific amount of work. Taken about 3 weeks to do these tutorials. So it's a tremendous amount of effort, but this qualifies the Q35 as operational. In terms of the tutorial and source code, that's all on GitHub. Here is the URL. You can take that from, and I'll put this in the link in the tutorials in YouTube. And the presentations are also up on GitHub as well. Just go up there and have a look, pull them down and play with them as much as you like. Same as the code. The code is available. The moment I publish it, it's available. And you can have a play and kick the tires. So that is the end of the Q35 chip family tutorials. The end.